Hey guys, what's up? It's Joe here. I make tech videos on YouTube, and today's problem is convert sorted array to binary search tree on Leetcode. Alright guys, so here we go. Given an array where elements are sorted in ascending order, convert it to a height balanced binary search tree. For this problem, a height balanced tree is defined as a binary tree in which the depth of two subtrees of every node is never differ by more than one. So we can see here we're given this sorted array, and one possible answer would be this binary tree we return here. So one thing to keep in mind is that if we have a sorted array here where if we look at it, a sorted array can be generated from some binary tree by using pre-order traversal. And when we do a pre-order traversal, we have the left nodes first, then we have the root, then we have the right. Similarly, we can look at this sorted array and we see that we have some root here, which let's say we start at the midpoint of this array, which is 0, and we see I have 0 here. And we know that because of this property that the left or the pre-order traversal always gives the left first, then the right last, we know that the -3 and -10 here must be on the right of this 0 node. So you can see here 10 are -10 and 3, and 5 and 9 are also on the right of this root node. And so we can do this step recursively for each spot. And when we go to this spot here, when we have an array of this size where we just have the -10 and 3, we have just the root being -3 because we take the midpoint from this between -10 and -3, and then we have -10 being on the left and nothing being on the right. And so from here we can see there's a couple of things we notice. That first, when our left index is greater than our right index, in the case here we had not enough space here to create another node, we will just return null. Then when we have, and that's going to be one of our base cases, and if left is equal to star, the right index and the left index are the same, or the array has pretty much only one element inside of it, we just want to return a new tree node of the nums at left. And then the third case is going to be our recursive case, where we take, if we were here at 0, we just recursively say, go ahead and generate the left and the right sides here using these subarrays here. And that's essentially how we'll be doing this. I won't write out the whole recursive case here because we will be doing that in the implementation. And so if we actually implement this, this will be O of n runtime. So let's get to it. So I'll leave this here just for reference. And what we'll do is we'll say first, if nums is equal to null, or nums.length is equal to 0, then we'll just return null. Otherwise, we will return a custom method that we will be implementing. So nums will have a start index here and a nums.length -1 here. And here we'll go ahead and make our custom method, and we'll actually just copy this. And we'll take an index, this will be our left, and then the index right. And we'll just be implementing exactly what we have here. So if the left is greater than the right, then we just want to return null. Otherwise, if the left is equal to the right, then we return exactly this. And num's at left. And then otherwise, we take tree node root. We'll generate this tree node, which will be our root in this case, and that'll depend on the midpoint that we have. So start, or this will be the left plus right divided by 2, and that's getting us the middle of the array that we currently have. And then we take this midpoint and take the value at that midpoint and create our new node. Then after creating that node, we'll take the root dot left, and we'll say this will be just recursively return the left side. The left side is the answer, so this will be left and the mid minus 1. And similarly, we'll take the right side here. And in this case, we will take mid plus 1. And we'll also take the right. And then afterwards, we just return the root. And we have a small error here. Let's see, this should be nums. And nums here. And that's it, guys. So not too bad of a problem. Pretty nice one to go through and implement. So yeah, let me know if you want more stuff like this. Please like, comment, subscribe. I'll see you in the next one.